Today we're taking a look at section 5.3. We're going to be looking at how to graph radical functions. And we're also going to be looking at transformations of radical functions. And lastly, we're going to take a look at graphing parabolas and circles as a bit of a review. So the parent function for the family of square root functions, this is just going to be our basic square root function f of x equals x. I want us to make a table of values here. So we're going to call this x and y. And we're going to think of some numbers we can take the square root of pretty easily. We cannot take the square root of negative numbers. So I know I'm not going to choose any x values that are negative. I might want to choose 0, 1, another number we can take the square root of is 4, and 9. So if I do the square root of 0, I get 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. And that's what they're showing us here, those points. And for our domain and range, the x value, the first x value we come to is 0. So x can be greater than or equal to 0. As far as the range goes, y can be greater than or equal to 0. And if I wanted to write that domain in interval notation, it would go bracket 0 to infinity, and the range would go bracket 0 to infinity. You need to understand that this is written in inequality form, and this is written in interval notation form. Sometimes people don't write it in the correct form. Big Ideas typically uses inequality form, but a lot of times on our tests we're going to be using interval notation. For the cube root of x, here's the way it looks. Why does it look that way? Well, let's make an xy chart. We're going to think of some numbers we can easily take the cube root of. We'll start here. I'll put 0 here. Cube root of 0 is just 0. The cube root of negative 1 is negative 1. The next cube root I would know would be negative 8. And the cube root of negative 8 is negative 2. If I go in the positive direction, cube root of 1 is 1. Cube root of positive 8 is positive 2. So our domain and range here, this is always going to be going over this way, and it goes around and up. And so our domain and range is all real numbers. And as an interval notation, though, we would write that domain as negative infinity to infinity, and that range is negative infinity to infinity. So there's where our parent functions come from, and you should know if you see square root of x, it's going to look like this. It's going to be that kind of a shape, going up like that. And the cube root of x is going to look like this, kind of this snake kind of shape is what some people call it. Okay, make a table of values based on the key points above. Graph the functions, state domain and range and interval notation. Also describe the transformation from the parent functions. All right, this is cube root. I'm going to look at these normal key points that we use for cube roots. Oops. These are our normal points that we use for cube roots. I'm ignoring everything else. I'm just thinking if I just had that parent function of y equals cube root of x, what are those key points? And that's what they would be. Now I'm going to apply my transformations. So one thing that would happen is, this is getting multiplied by negative 1. If I have a function and I have a negative out in front, what that means then is that I'm going to have that reflection in the x-axis. So if I reflect in the x-axis, that is going to take all my points and reflect them over. So now this is going to be positive 2, positive 1, positive 0, negative 1, negative 2. So those would be my new y values. And then this subtract 1 is going to take everything down 1. So take this down 1, down 1. Okay? And so that's the way it's going to look. Instead of it going like this, it's going to go like this now, and it's been shifted down 1. We're just doing a real quick sketch of it. It's not great, but so it's going to look kind of like that. If we wanted to, we could check it. If I look at my thing here, my calculator, I'm going to do negative, I'm going to go under math, get cube root of x minus 1. I'm going to look at my table, and I'm just going to check my table out. So at negative 8, I should have 1, negative 1, 0, 0, 1. At 1, I should be at negative 2, and then at 8, we're at negative 3. So we can see that that table of values is correct. If I wanted to graph it, I can see that this is the way it looks. And I could have been a little more exact with this. I just kind of ran out of room there. All right, let's look at the next one now. Square root of x plus 2. Now we're looking at our normal, I need to do domain and range. Domain is still the same, and range is still the same. All right, for this one, my parent function is radical x. I know those key points I found earlier, I could take the square root of that. Those would be like my key points normally. And now I'm going to go up 2, so everything's going to get 2 added onto it. And so those are going to be my new key points. And so I can say then that what's going to happen is it's going to go up 2. Those would be some points that would represent it. And the transformation, like I said, is up 2. My domain would now be, looking at a sketch, it's going to look like that. So my domain is still going to be from 0 to infinity, but the range is going to be from 2 to infinity now, because the range got moved over here up 2 units. Okay? All right. This is a review of all of our transformations. If we want to go in the horizontal direction, left or right, if I want to go to the right, wherever we have an x, here's the function. Wherever we have an x gets replaced with x minus 2. That takes us to the right. If we want to go to the left, x gets replaced with x plus 3. Up and down, everybody does well with. If we want to reflect in the y-axis, x gets replaced with negative x. In the x-axis, we put a negative, we multiply the whole function by negative 1. To have a shrink horizontally by a factor of 1/3, a lot of people mess this up, x gets replaced with 3x. A horizontal stretch by a factor of 2, x gets replaced with 1/2 x. If we want to have a vertical stretch by a factor of 4, the function gets multiplied by 4. A vertical shrink by a factor of 1/5, the function gets multiplied by 1/5. All right, let's look at this example. Write a rule for g if g is a vertical stretch by a factor of 2, followed by a horizontal shrink by a factor of 1/2, then a shift to the left 3, and a reflection in the y-axis for this graph. All right, so we have our function. I'm going to do this one step at a time. Vertical stretch by a factor of 2. That means I'm going to take both of these two terms and I'm going to multiply them by 2. Multiply this term by 2. And multiply this term by 2. The whole thing gets multiplied by a factor of 2. Followed by a horizontal shrink by a factor of 1/2. Think about it. Horizontal shrink by a factor of 1/2. When it's horizontal, it's the opposite of what you would think. X has to get replaced with 2x. Look at that. Right here, wherever this x is, I replace it with 2x. Everything else stays the same. Shift to the left of 3. I take my function. Wherever I have an x, if I'm going to the left 3, this x gets replaced with x plus 3. Then I have this plus 3 and minus 2. Look at it again. This stays the same, this stays the same. X right there gets replaced with x plus 3. That plus 3 still stays there, and the subtract 2 stays there. I'm going to simplify. I can distribute this. So this is going to be 2 radical 2x plus 9 minus 2. Okay, and then the last thing we have to do is a reflection in the y-axis. Okay, so I take this to do a reflection in the y-axis. That means my x has to get replaced with a negative x. So my last transformation is this. X gets replaced with negative 2x. Everything else stays the same. And there it is. Sometimes people check these and they feel like it doesn't look right. But I want to show you what happens here. So there's our original. Here's what we think is the answer. When we have this vertical stretch by a factor of 2, that shifts everything. So it actually even changes that point. So you got to keep that in mind. I want you to take a look at how the result looks. Here's the original function. Here's the new one. So look at everything that happened. We had this function. It got stretched vertically. That made it look twice as steep as it used to, and it even moves that point. Then we had to go to the left, so that's going to take, we did the horizontal shrink next. The horizontal shrink is actually going to take it this way. We had to go to the left 3. So when we went to the left 3, that took it way over here, and then we reflected it in the y-axis, so it went over here. So that is correct. All right, let's go to that. We're just going to graph, this one is pretty easy. Let's just identify what happens here. What happens with this? What does that do? Well, that would be a reflection in what? Y-axis, right? From our parent function. Then what does this do? Takes it up 1. Alright, we're not going to bother graphing that. Yeah, why not? It's fun, right? So normally our cubic function looks like this. We're going to reflect it in the y-axis, so instead of looking like that, it's now going to look like this, and it's going to go up 1. We're not going to be exact, but it should look something like that. If I had used my points, I could tell exactly what it's going to look like. We'll do this one with our points. So this is a square root function. To the 1/2 means the same thing as this. Okay, so normally when we're looking at that parent function for radical x, we have these points. Okay, now we're going to apply our transformations to these points. So first thing that happened was we had x minus 5. That's going to take all of our x's and it's going to shift them to the right 5. Okay, still have these points. Okay, now I'm going to look at this. So when I do this 2, that's going to take all these values and it's going to multiply them by 2. And now the last thing that happens is we subtract 4. That's going to take all these points down 4. Okay, so there's what we're saying our new key points would be. I should have moved this axis over. Let's go by 2's. So at 5, we're going to be at -4. I'm going to go by 2's this way too. 6, we're at -2. That's good enough. Okay, so there's the way we're saying that it's going to look. Our domain here is going to be from, our first point that we could use would be 5 to infinity. The range is normally from 0 to infinity, but now it's going to go from -4 to infinity. Remember, in big ideas, they would write these as inequalities. X greater than or equal to 5, y greater than or equal to -4. If I wanted to do a quick check on this, just to check my points, might as well check that out, how that's done. Look at the graph first, see if it looks right. Looks pretty good, doesn't it? Let's look at the table now. And we can see our points. 5, -4, 6, -2, 9, 0, and 14, 2. Right on. Okay. Describe this transformation to go from here to here. Look what happened. Everything got multiplied by a -1. What does that mean when everything gets multiplied by a negative? That's right. Reflection in the x-axis. Okay, write a rule for G. If G is a horizontal shrink by a factor of 5, 6. So horizontal shrink by a factor of 5, 6 means that my x is going to have to get replaced with the reciprocal of that. So my first step is going to be that I've got the cube root, 15 doesn't change. X gets replaced with 6/5 x plus 1. Oops, let me just simplify that. So 15 divided by 5 is 3 times 6 is 18. There's my first step. I did this. Followed by a translation 10 units to the left. Well, that means wherever I have an x, I'm going to have to replace that x with x plus 10. And so my final answer is going to be this. Well, I wanted to distribute. Hold on. That's 18 and 180, so that's going to be 18x plus 181. There's my g function. So that function right there is going to do all of that. All right, check out the next one. Use a graphing calculator to graph this. Identify the vertex in the direction that the parabola opens. Well, if I want to graph this on my calculator, I have to solve it for y. So I've got to get y squared is equal to, I've got to take this over here, 8x minus 5. I always like to use y squared over here, so I'm going to use the symmetric property and switch this around. Now I can take the square root of both sides. If I take the square root of an equation, it's plus or minus. So this is what I'm going to get. Tells me to graph it on the calculator. I have to graph two of this, two radicals. Alright, I'm going to graph it. Here's the way it looks. Okay, now these actually do meet. The calculator's not super great at that, kind of messes that up. But notice how I can see that if these met, they meet right about there. I need to know what that point is. Well, that point is going to be whatever makes this function equal 0. So if I want to find it, I'm just going to set this equal to 0. I'm going to set my function equal to 0. I'm going to square both sides. And 5/8. That's going to be the vertex coordinate. Okay, so I'll just graph that. So 5/8 is right about there. And I'm going to want to get a couple more points just to have it a little more accurate. And I'll just use this one. 5, I'm almost at 6. Looks about like that. Okay. Alright, last one. Use a graphing calculator to graph this one. Same kind of thing. Want to get y by itself. If you want to try it on your own, that would be a great thing to do. If you want to watch, you can do that as well. So I want to get y squared positive, so I'm going to bring it over here. Now I got to get y by itself. So I'm going to have to subtract x squared. And now I'm going to have to take the square root of both sides. Do not make this mistake. People say, oh, I'm going to take the square root of this and the square root of that. You can't do that if it's addition or subtraction. If it's multiplication, you can. For example, if I have the square root of 49x squared, I can take the square root and get 7x, absolute value of x. But if I have x squared plus 49, there's nothing I can do with that. I just have to leave it that way. There's no other simplifying. So there's the way it would be. Let's put it in now. And this shape looks like an oval, doesn't it? But it's really not an oval. If I do a zoom square, it's going to make it look more like the way it should. The zoom square just makes it so that the screen turns into a square screen instead of rectangle. Anyway, this is a circle. This is something you should know. Whenever you see right here, this is actually x squared plus y squared equals 49. You need to recognize that this kind of equation is a circle. And this is a circle with a radius of 7. All you got to do is take the square root of that. Oopsie. Oh. And we go out 7 in every direction. I'm just going to call that a 1. 1, and then 3, 5, 7, and then 2, 4, 6, 7. 1, 3, 5, 7, and 2, 4, 6, 7. Okay, and so the intercepts are going to be, right here is an intercept, 7, 0, here's 1, 0, 7, here's 1, negative 7, 0, and here's 1, 0, negative 7. All right, that's all there is for that section.